Okay, today's about good definitions, and the goal is to identify a good definition, understand the meaning of terms like bisector and perpendicular. And I got to tell you that a couple of these things are misconceptions for students, so make sure you pay close attention, especially when we go through these definitions here. Okay, let's start by defining midpoint. Midpoint, what's a midpoint? Anyone know? Chase?
Is it like the middle point on the line?
Yeah, like if you have a line segment, a midpoint is like the middle point. It's the point at which, if I had segment AB, it's the point that would cut that line perfectly in half. That is called your midpoint. So if we called this C, then point C, if this part was congruent to that part, and notice how I use those markings there. One little mark, so AC is congruent to CB. Therefore, C is the midpoint. Of AB. Okay? Very good. Notice since I have one little slash here and one slash here, that means this segment is congruent to the same segment that has that slash. Okay, perpendicular lines. What are perpendicular lines? Go ahead and tell your neighbor what you know about perpendicular lines.
They're opposite of parallel.
Yeah, they like intersect each other.
Okay, volunteer. What are perpendicular lines? Hold on. It is Holly, right? Emily? Okay, go ahead. Help me with your name. Megan. All right, Megan.
It's when two lines intersect to get four right angles.
Two lines intersect to get right angles. Now, they could be four right angles if the line goes through. Okay? So, in this case, as Megan said, Megan, right?
Mm-hmm.
Yeah. All right. As Megan said, there we got four right angles. I made those angles all different sizes, so it looks cool. Okay? So, we have four right angles. Or, it could just be, they could just intersect like that. You get a right angle there and a right angle there. All right? Not a great right angle, but okay. Yes, sir.
Do they have to be right angles?
They have to be right angles. That's what makes them perpendicular. Okay, perpendicular means they intersect at right angles. So, for instance, if this was, let's deal with this one. Let's say this is A, this is B, this is X, this is Y. The way we write that is AB is perpendicular to XY. Okay, notice we use that little upside down T. That's the symbol for perpendicular. Okay. Any questions there? Perpendicular bisector. Well, perpendicular, once again, means it hits at a right angle, but a bisector means it cuts it in half. So it's like combining these two together. You have a line. We're going to call that line JK. Seriously, JK. Okay? JK. And from JK, we're going to intersect that at a right angle. Okay? And halfway. So we'll call that M in the middle. And that M is going to actually be our midpoint, and we're going to intersect that line at a right angle, which makes that a perpendicular bisector. So M is the midpoint of JK, and if I put another point up here and call it P, I now have, that's a ray that I've drawn, but if I extend it through, okay, there, now we have a line. Okay, and we have point M. All right, I have PM, not B. PM is perpendicular to JK. When this line's perpendicular to that line and this point is the midpoint, so in other words, JM is congruent to MK, then that's a perpendicular bisector. It cuts in half. The word bisect means it cuts in half. Now that's the part where students get confused. They start thinking any line that's perpendicular becomes a bisector. That's generally the mistake I've seen. It's not any line. It has to say perpendicular bisector. Okay? Bisecting means it cuts it in half. Okay? So make sure you add that to your note. Cuts in half. Okay? Bisector. So which means an angle bisector would cut an angle in half. So any angle, in this case if I have x and y and z, angle x sorry, I should add this other piece in here real quick. Let's call this F. Angle x, y, f is going to be congruent to angle f, y, z. Okay, angle f, y, z. So that means this little piece is congruent to that little piece. Okay. It's not the best drawing of it, but there you go. These are congruent, meaning that's an angle bisector. So YF, ray YF, is an angle bisector of XYZ. Okay, so that's a ton of our definitions there. Any questions on those? Can help us today quite a bit. All right. So I'll hang this up here if you want to see it later. The 3 properties of a good definition is on the bottom of page 32. And I know you don't have your books, but I just want you to know that we're going to page 32 and we're going to list some properties of a good definition. Okay? Those are our 3 properties. Now you don't have to write them verbatim. I want you to read through them right now though. Okay? So check those out. A good definition uses clearly understood terms, commonly understood, previously defined. They're precise. They don't use words like large or sort of or some. They don't use those ambiguous words. And it states what it is versus what it is not. A poor definition of big is saying big is the opposite of small. Okay? Big is an ambiguous term. So if I take a look at, say, like this one right here, and I have bisectors, study the diagrams below and write a good definition of a segment bisector. Okay? I want you to try that right now. Or you don't have to actually write it out. You can go ahead and explain it. Give a good definition to your neighbor there, and then we can write one out. What's a good definition of a segment bisector? Grace? Okay, segment bisector cuts a segment in half. Chase?
The segment bisector cuts the segment at its midpoint.
Okay, segment bisector intersects or cuts a segment, intersects a segment at its midpoint. Okay, cutting it in half. All right, maybe combining the two. Izzy?
A segment bisector is when a line cuts it exactly in half, so both sides are congruent to each other.
Okay, so adding the terms congruent in there, so the remaining parts are congruent to each other. So segment bisector cuts a line in half, a line segment in half, intersecting at its midpoint, and creating 2 congruent parts. Okay, those are all good. Go for it. Okay, you could relate it to a perpendicular bisector. Oh, yeah, it is. It is. Yeah, a perpendicular bisector is a segment bisector. It's just a special type of segment bisector. Cuts its perpendicular. Very good. Emily, right? Yeah. Woohoo. Okay. Any questions there? All right, I'm 2 minutes past my allotted time here. Sorry, I'm going into overtime. Perpendicular lines, we've talked about those. We've talked about the symbol. But there it is. That's what you'll see in the book. If you want to add it to your notes, it's on page 33. If you want to reference it later, you can just say it's page 33. So we have our perpendicular lines. They form the right angles there. Notice they don't have to cut, they don't have to be perpendicular bisectors. Can a line have a bisector? Tell your neighbor if a line can have a bisector. Yes and no, and why? Okay,
Thank you, Ken.
time's up. Can a line have a bisector? Who says yes? Who says no? Why not? Yeah,
The line
course.
just keeps going on, so there is no midpoint.
good. The line goes on and on forever, so there's no midpoint. So it can't have a bisector. Good point. Okay, if PQ is perpendicular to RS, what is the measure? That's what this means. This does not mean M times. Pay attention to that. That means what is the measure of angle PTR? PTR. This guy right here. What is that? Well, dude, look what I just did. It's 90 degrees. Yeah, it's a perpendicular. It's perpendicular, so the measure has to be 90 degrees. I like to put that up there, not necessarily for this, because I think you pick that up at the measure of that. Okay? If they're perpendicular, then they intersect at right angles. But I really want you to look at the letter B. Which lines, if any, are perpendicular? Explain. Go ahead and talk it over with your groupie. I'm going to hand out your assignment while you're doing it. Okay, volunteer, please. Boy, same people. Do I have a new volunteer? Nothing against Madison or Carson or Grace. Someone else as a participator. Logan. So you're saying line C, what? CG and D. Oh, E. EA. So these two right here. I don't think those will make perpendicular because those add up to 95. Huh. Uh-oh. Yes, Diamond.
I said B, F, and DH.
All right, let's try that one. BF and which one? DH? That work? Let's see, we have 40 plus, I don't know what that is. 50? How do we know? Well, let's look at this.
The angle across from it is 50 also.
Oh, yeah, these are called vertical angles if you didn't know that. That's something that we'll learn there, but that is 50. Yeah. How many new vertical angles? You've seen that before. Okay, good. So we have 55 and 35. That makes a grand total of 90. And if that's 90, a straight line makes what?
180.
180. So if that's 90, this has to be 90 without even knowing that's 50. So that is correct. Very good. Okay. Any questions there? Good job. Logan gave me something to talk about. Thank you, Logan. Well done. All right. Perpendicular bisector of a segment is a line or segment or ray that is perpendicular to a segment at its midpoint. That's what we've talked about. If you know JK, seriously, is perpendicular bisector of XY, what can you conclude about the angles and segments in this diagram? What do you guys think? Come up with two things you conclude about angles and segments. Okay. What do we got? What can we conclude? Diamond?
All the angles are 90 degrees.
All the angles are 90 degrees. How come? Someone else? Someone new? Come on. Megan?
That Z is the midpoint of XY.
What's that?
That Z is the.
Oh, Z is the midpoint? Okay, that's true. Yeah, because it's a bisector, right? How do we know these are 90? Go ahead, Jackson.
It said that JK is perpendicular bisector.
Good. Perpendicular means it intersects at 90 at the midpoint. So Z is the midpoint. Anyone else? Go ahead, Cameron.
Segments XZ and ZY are congruent.
XZ is congruent to ZY. Well done. Yeah, does everyone see why that is? It's a perpendicular bisector. Cuts it in half. Okay? So, if you know JK is the bisector of XY. So does that mean JZ? JZ. All right, and ZK? Does it mean that those are congruent? Who says yeah? Yep, those are congruent. Who says nope? Who says I really don't know? I'm just kind of hoping you give me an answer. Some of you don't say anything. How many of you? Raise your hand, dude. Everyone raise their hand. Okay, if your neighbor doesn't know how to raise their hand, help them out. Okay, how many say yes, JZ is congruent to ZK? You know that based on what they've given you. How many say nope, it's not? How many are just not sure, even if you voted for one of the others? The answer is no. Okay, this says that JK is the bisector of XY. It does not say XY is the bisector of JK. So we cannot conclude that these are congruent, even though they look congruent. In geometry, we have to have it told to us, or we have to be able to prove it. In this case, we cannot. Okay? Any questions there? Okay, take a look at your assignment, please. Your assignment is the mixed side today. Mixed side. All right. Very good. Ready and go.